Okay. We have to apply the side, 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 and side angle, side triangle similarity theorem. So that's our learning objective for today, to apply those two. Ready. Okay, so yesterday we went over our beautiful angle. And that said, as long as we have two angles that are congruent and corresponding to two triangles, we can go ahead and prove that those two triangles are similar to each other. Today, we have one that states that we have three sides, side, side, side. And the other one that states that we have a side angle side. Very similar to our congruence theorems, yet different. Because this time, we are not proving that our sides are congruent. We're proving that our sides are proportional. Okay? That's the key word here, proportional. Okay? So, with that said, first one states if the three sides of one triangle are proportional to the corresponding three sides of another triangle, then the triangles are similar. The second one states if the two sides of one triangle are proportional to the corresponding sides of another triangle, and their included sides, so remember that side that the angle that they share, their included angles, are congruent, then the triangles are similar. Two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the triangles are similar. Go ahead and copy this down in your notes. So you guys down. So this one says determine whether the given triangles are similar. We're going to go ahead and justify our answer by stating one of the beautiful similarity theorems here in this case. Okay, so we have our beautiful triangle GHJ, GHAJ, and LMN. We're going to go ahead and find out if they're similar to each other. And we're going to go ahead and figure out which of the theorems we're going to go ahead and use to prove that they are. Okay. So with that said, go ahead and copy this one down. Okay. Ready? Yes. Okay. All right. So by looking at our beautiful pair of triangles, what type of information is given? Do we have angle measurements? Do we have side measurements? Do we have a combination of measurements? Roland? We have side measurements in this case. So therefore, we have three types of theorems. Which one do you think we're going to use? Side, side, side in this case. All right, so let's go ahead and try and see. We're going to go ahead and start with our smallest side first. Here's my smallest side. I'm going to go ahead and start with triangle GHJ. And GJ should be corresponding to what side from triangle LMN? LN by their sides. Okay, so this is my figure 1, my figure 2. So F1, F2. So this should be 4/6. Okay, so here is one side. Now let's go ahead and do the next side. So we have, let's see, GH now. This one should be corresponding to 12 or LM. LM, there you go. Let's go ahead and create our beautiful proportion, 8/12. And the last one, let me go ahead and do this one in blue. HJ should be corresponding to MN. Okay. So this one is 10/15. Now you can go ahead and solve it both ways and see if they're proportional to each other by creating our proportions and seeing if our left side equals our right side, or by simplifying the ratios. Which one do you guys want to do? Okay, simplify. So let's go ahead and simplify our beautiful ratios. Our first ratio, 4/6 divided by 2, we get 2/3. Our second ratio, what can we simplify it by? By 4, we get, okay, check. Now we have to prove that the last side, divide by 5, and we get 2/3. Our three ratios, are they congruent to each other?
Yes.
Yes, they are. So therefore, are my triangles similar to each other? Yes, they are. They are similar by using our side, side, side. Now we can go ahead and state our similarity statement. Similarity statement. Okay, let me go ahead and start with triangle GHJ. GHJ is similar to triangle. G is corresponding to? Is it MLN? Which one? L in this case. H is corresponding to? M, and N or J is corresponding to? N in this case. So here's our correct similarity statement. Remember that the order in our vertices or the points in our beautiful triangle, the way that we stated matters. Our order matters. Okay. So our statement is done. We use side, side, side. We use the ratio method. We simplified our ratios, and we were able to identify that our ratios were indeed correct or proportional to each other. Okay. Ready for the last one. Woo-hoo. All right, let me go ahead and save an image. Let me go ahead and clear. Did everybody have that? Just making sure. Okay. All right. So example number 2, determine whether the given triangles are similar. Justify your answer. We're going to go ahead and use either of the 3. Remember that we have angle, side, 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 and side, angle, side. Which one are we going to use? Side, angle, side. Why not side, side, side? There's an angle involved, okay? And we're also missing some more information. So we have a side, we have an angle, we have another side, we have a side, another angle, and another side. Okay, perfect. Everybody has this? Okay, so let's go ahead and first is we're gonna use side angle side. This one right here. We have our congruent angle. Do we have a congruent angle? Yes, we have angle NMP and RMP that are congruent to each other. So we have that angle there. Okay, check. Now we have to check that our sides are proportional, not congruent, proportional. So let's go ahead and create our ratios. Figure 1, figure 2, figure 1 over figure 2. All right, what side do you guys want to start with first? 4. Okay, so 4 is going to be corresponding to 6 in this case. Okay, so these two are corresponding. So 4 over 6. And our next side is 8 and it's corresponding to 12 in this case. So 8 is this little piece right here. 12 is the entire segment over here. So it's 8 over beautiful 12. So which way do you guys want to do it? Simplifying? Okay. Divide by 2, divide by 2. We have now 2 over 3 again. Divide by 4, divide by 4. We have 4 over, not 4, sorry, 2. 2 over 3. So does 2 over 3 equal 2 over 3? Yes, so we do have a proportional. Therefore, by side, angle, side, we were able to state that they are similar. Let's go ahead and state our beautiful similarity statement. Statement. All right, so triangle, which one do you guys want to start with? M and P, NMP, MNP. Similar to triangle, M is going to be corresponding to M, N is corresponding to R, and Q to P. There you go. Not too bad, huh? Not too bad. All right. All right, so I'm going to go ahead and give you guys your beautiful worksheets for right now.